This video is about directional derivatives. Directional derivatives are used to represent an instantaneous rate of change in a given direction. So, the directional derivative is defined as the limit as h approaches 0 of f of a plus h cosine theta, comma b plus h sine theta, minus f of ab, all over h. Alternatively, it can be defined as the partial derivative of x and the partial derivative of y, otherwise known as the gradient, minus the unit vector in a given direction. This example is from chapter 14.6, it's number 18. We need to find the instantaneous rate of change at a point 3, 2 in the direction 5 over 13, 12 over 13, with f of x, y being 3x squared plus y cubed. So first we want to find the partial derivative with respect to x at the point 3, 2, which will come to 6x, and then that's going to equal 18. Then we have the partial derivative with respect to y, which is going to be 3y squared, which will come to 12. And then we have the unit vector in the given direction. And when we find the magnitude of 5 over 13 and 12 over 13, we find that its magnitude is 1, which means that it is actually the unit vector, so we can use that exact vector in our directional derivative. Now we have to plug this into our formula. And when we take the dot product, we get 18. So the directional derivative in the direction of 5 over 13, 12 over 13 at the point 3, 2 is 18. Now we have chapter 14.6, number 24. H of x equals e to the negative x minus y at a point p equals ln2, ln3 in the direction vector of 1, 1. So we find the partial derivative with respect to x at ln2, ln3, which is going to come out to negative 1 over 6 after substituting in for the point into the partial derivative. Well, we're going to do the same thing with the partial derivative with respect to y, which turns out to be the same thing because the derivative with respect to each one is actually the same for this function. And then we have to see what our unit vector is. And when we take the magnitude of 1, 1, we find that it is the square root of 2. So to find the unit vector, we divide each component by square root of 2. So our unit vector is going to be 1 over the square root of 2, comma 1 over the square root of 2. When we plug that into our formula and take the dot product, we find that the unit vector, that the directional derivative comes out to negative radical 2 over 6. And that's directional derivatives.